Question 14. So to factorise this expression here, I can see that x is the common factor, so that's going to come outside my bracket, and an x times x makes the x squared, and x times 7 makes the 7x factorised for 1 mark. Part B is the more traditional type of quadratic we're used to seeing, so this one's going to end up being double brackets, and if I look at the minus 10 and the plus 16, I know that it's got to be y and y, minus 8 and minus 2. Part C, slightly trickier because my coefficient of the t squared is now not 1, it's 2. But again, this is going to end up with double brackets, and my solution here is going to be 2t plus 1 and t plus 2. And if I'm not sure about this, I can use a grid method to multiply the thing out and double check I get back towards that. Okay, part I, t is a positive whole number. This expression can never have a value that is prime. Explain why. Well, the secret to answering this kind of lies in the bit before it. I can see that this expression is made from 2 distinct factors. Now, prime numbers can still be made of 2 distinct factors, but what happens is one of them must be 1 and one of them has got to be the number itself. So all I need to do is show that neither of these two brackets can be the value 1. And the way I'm going to do this lies with this sentence here. T is a positive whole number. So let's go, we're trying to make 1, let's go with the lowest possible number it could be. Let's say t is 1. If t is 1 here, this bracket becomes 3, so that's no good to us. And if t is 1 here, this bracket also becomes 3, so that's no good to us either. So the explanation for this is that this expression, 2t squared plus 5t plus 2, is always a product of 2 factors. And that's the bit up here where we said that this was times by this, so I've shown that there are 2 factors of this thing. The other thing I needed to add on is that neither of these are 1. Okay, and that's that question answered.